will see some elementary functions Z transformation. So first one, sixth one, sorry, prove that Z transformation of a power n by n factorial which is equal to e power a by z. Now given f of n which is equal to a power n by n factorial, we are taking f of n as is a power n by n factorial. We know z transformation formula, z of f of n which is equal to summation n is equal to 0 to infinite f of n z power minus n. So replacing f of n by a power n by n factorial, you will get z of a power n by n factorial which is equal to summation n is equal to 0 to infinite a power n by n factorial z power minus n. Z power minus n can be written as 1 by z power n. So next step, we are going to group a power n into 1 by z power n as a by z whole power n. So you will get summation n is equal to 0 to infinite a by z whole power n into 1 by n factorial. This can be written as a by z whole power n by n factorial, right? So now giving values of n and add up, so you will get n is equal to 0. So a by z whole power 0, 1, 0 factorial 1. So first term 1. Second term a by z by 1 factorial plus third term a by z whole square by 2 factorial plus etc. etc. We know 1 plus x by 1 factorial plus x square by 2 factorial plus etc. etc. is nothing but e power x. Instead of x, here you are having a by z. So replace x by z, you will get e power a by z. Therefore z a power n factorial which is equal to e power a by z. So here we are going to see some standard results. So like before, we can prove all those things, right? These are all considered as a formulas, right, for z transformation. For z of k is equal to k z by z minus 1, z of a power n z by z minus a, z of minus 1 power n z by z plus 1, z of n z by z minus 1 square, z of n square z square plus z by z minus 1 whole cube, z of n cube z cube plus 4 z square plus z by z minus 1 power 4, z of n a power n a z by z minus a whole square, and z of 1 by n log z by z minus 1, z of 1 by n plus 1 z log z by z minus 1, z of a power n by n factorial e power a by z, z of r power n cos n theta z into z minus r cos theta by z square minus 2 z r cos theta plus r square. Similarly for sin theta, z r sin theta by z square minus 2 z r cos theta plus r square. Z of cos n pi by 2 is equal to z square by z square plus 1. Similarly, sin n pi by 2 is equal to z by z square plus 1, right? Now we will see some special property of z transformation, that is differentiation in the z domain or multiplication by n. Suppose a function is given, f of n is a given function, then if you want to find the z transform of f of n into n, multiplication by n, that means z of n into f of n. So we can use this property, then we can easily find our values, right? Statement. So if z f of n which is equal to capital F of z, then z n into f of n which is equal to minus z into d by dz of f of z, derivative of f of z with respect to z is nothing but z transformation of n into f of n, right? We'll see the proof. F of z which is equal to z of f of n is equal to from the definition of z transformation, summation n is equal to 0 to infinite f of n z power minus n. Now differentiate with respect to z, so you will get both sides, right? D by dz of differentiation with respect to z of f of z which is equal to summation n is equal to 0 to infinite f of n. We are differentiating z power minus n. So we know differentiation of x power n with respect to x, d by dx of x power n, which is equal to n into x power n minus 1. Similarly, here we are having, instead of n you are having minus n. So n into minus n into x power, instead of x you are having z power n minus 1 minus n minus 1, right? So that is equal to, taking minus outside, you will get summation n is equal to 0 to infinite f of n z power minus n. We are splitting the power of z into z power minus 1. Taking z power minus 1 outside, you will get minus z power minus 1 summation n is equal to 0 to infinite n f of n z power minus n. So from the definition of z, this summation n is equal to 0 to infinite n f of n z power minus n is nothing but z transformation of n f of n, correct? So you will get, which is equal to minus 1 by z of z n into f of n. So d by dz of f of z, which is equal to minus 1 by z of n f of n. So multiplying both side by minus z. So you will get minus z d by dz of f of z, which is equal to z of n f of n, or z of dz of. Next, instead of f you are having n power p f of n, which is equal to minus z power p z power p f of z square f of n, then which is equal to minus z square d square by dz square, 2 times derivative, right? Second derivative you have to take of f of z, right? Thanks. We'll see you in the next video.